friends. Welcome to our mathematics program for grade 9. Today we're going to look at an interesting chapter in mathematics which is called matrices. Actually, we're going to have 3 videos on matrices. So this one is the first one. So we're going to learn how to interpret a matrix, determine the order of a matrix, and identify the different types of matrices. Right, so what is a matrix? A matrix is simply an array of numbers, right? And each number of that matrix, it is called an element. So I say it again. A matrix, it is an array of numbers, and each number is called an element. Now, sometimes you will see matrix, but you can also see the word matrices. Matrices is the plural of matrix. Let's see some examples of matrices. 1, 2, 3, 5, 9, minus 2, 3, 7, 12, minus 8, 7, 9, 2 minus 4, 0. What can you see about these matrices? Well, they are numbers, right? You can see that. And these numbers are within brackets, right? These are array of numbers. Right, so we know that each number of a matrix is called an element. But these elements, how are they arranged? They are arranged in rows and columns. What are rows? Rows are simply the horizontal entries. And columns, these will be the vertical entries. Okay, let's see an example now. Well, you've got a matrix. The matrix contains numbers 1, 8, minus 2, 3, right? So these numbers are called elements. That's right. Okay, so we've got a matrix, we've got elements of these matrix. What do we mean by the rows and the columns? Let's see that together. So 1, 8, that's a row, exactly. So this one will be the first row. And minus 2, 3 will be the second row. So in this matrix, we've got 2 rows, row 1 and row 2. Do we have any columns? Yes. 1 minus 2 will be the column 1. Do we have another column? Yes, we have. 8, 3 is column 2. So what can we say about this matrix? We have 2 rows and we have 2 columns. Now, this is important, the order of the matrix. What do we mean by that? What is the order of a matrix? The order is simply the number of rows and the number of columns of a matrix, right? So the number of rows and the number of columns is called the order of the matrix. Now, when we talk about the order, we always state the rows first and then the columns. This is by convention. You never state the columns and then the rows. It's always the rows and then the columns. For example, you've got a matrix 2, 3. Right, how many rows do we have? Well, you've got only 1 row, right? And how many columns do you have? You have 1 column and another column. So in this matrix, the order will be row times column. So 1 row times 2 columns, and the matrix is, we call it a 1 by 2 matrix. We take another example. Right, so here, 2 minus 2, 1, 3. What do we have? Well, 2 minus 2 is row 1. 1, 3 is row 2. Do we have any columns? Yes. 2, 1, that will be column 1, and minus 2, 3 will be column 2. So the order of this matrix, always the order is row times column. So that will be 2 rows and 2 columns. That is a 2 by 2 matrix, right? So the order of this matrix is a 2 by 2. Another word for order, sometimes you will see the dimension. The dimension of the matrix is a 2 by 2. Let's take another example. Minus 2, 1, 0. Okay, how many rows can you see in there? Let's see it together. So that will be row 1, row 2, and row 3. Do we have any columns? Yes, we've got 1 column. So the order of the matrix will be row times column, that is 3 rows and 1 column. And it is a 3 by 1 matrix. Now, we've seen that a matrix consists of an array of numbers, right? We've talked about the order of the matrix. Now, what is interesting to know is, are there different types of matrices? Yes, you have. Let's see that together. So, the first one is a row matrix. A row matrix is a matrix with only one row. So, for example, 2, 1, 4, 5, 6, minus 1. These are row matrix. Now, if a row matrix consists of only one row, a column matrix will consist of only one column. For example, minus 5, 3, 8, 12, 0. These are column matrix. Now, you have also what we call a null matrix or a zero matrix. According to you, what is a null matrix? Well, it is a matrix where all the elements of this matrix will be equal to 0. A square matrix? Well, a square matrix is a matrix with the same number of rows and columns. For example, you've got a 2 by 2 matrix, the same number of rows and the same number of columns. A 3 by 3 matrix, the same number of rows and the same number of columns. A diagonal matrix is a square matrix. You know what a square matrix is now, with all the elements 0 except for those in the leading diagonal. So what does that mean? We know that a diagonal matrix is a square matrix, right? You know that a square matrix has the same number of rows and the same number of columns. So the first one, this is a 2 by 2 matrix, which is a square matrix. Now, look at the leading diagonal. This is the leading diagonal, right? And the elements are non-zero, while the other elements are 0. Exactly. This one is a 3 by 3 matrix. Leading diagonal, non-zero, other elements, 0. So this is a diagonal matrix. Now, an identity matrix or a unit matrix, you will use that matrix very often. Now, the identity matrix is a matrix where all the elements of the principal diagonal are 1 and the rest 0. Okay? You know what the leading diagonal is? So, here it is. The elements of the leading diagonal are 1 and the rest are 0. Equal matrices, this is an interesting concept in matrices. Two matrices are said to be equal if the corresponding elements are identical and they have the same order. What do I mean? Look at matrix A and matrix B. Okay, first thing, these two elements, the elements in matrix A and the elements in matrix B are equal. We've got 2, 0, 0, 1 in both matrices. So the elements are identical. Okay? And what about the order? Here you've got a 2 by 2 matrix, and this one is a 2 by 2 matrix. So they have the same order. So if the order of two matrices are equal and the elements, the corresponding elements are identical, we say that the matrices are equal. So we've seen the different types of matrices, right? We have talked about equal matrices. Now what we are going to see is how to work with equal matrices. For example, find the value of the unknowns in the following. The unknown variable, for example, in the first one, it is x. The unknown is what we need to find. So we've got 4 matrices. We're going to see how to solve these. Let's take part A. Part A, we say that x equal to 5. So this is rather simple and direct. Here, x is 5. Simple, right? Let's consider part B. What do we have? We've got 2x equal to 2, 3. Okay, what is the order of this matrix, the first one? Well, we've got 2 rows and 1 column, so that is a 2 by 1. Here, same thing, 2 by 1, right? Order, same. Now, the elements, the corresponding elements, here you've got 2, okay? So, if we got 2 here, x will be equal to direct x equal to 3. So that's not very hard. Now let's consider this one. We've got 2 by 2 matrices, right? Corresponding element, you've got 0 here. What about the 2x? So the 2x will be equal to 4. And the 3 equal to y. So how are we going to solve that? Now 2x equal to 4. Simple equations. You've done that earlier. If 2x equal to 4, x will be equal to 4 divided by 2. That's right. So x equal to 2. What about y? That's direct. Y equal to 3. This one is a bit more difficult, right? So let's do it together. What do we have? 3y equal to 15. That's right. And then, so if 3y equal to 15, what are we doing? We are equating corresponding elements in both matrices. So if 3y equal to 15, y will be equal to 15 divided by 3, that is 5. Let's take the second one. 2x will be equal to 6. What is that? Always equating corresponding elements in both matrices. Now, if 2x equal to 6, x will be equal to 6 divided by 2, which is 3. The last one, this one is simple. Z will be equal to 11. Right, now a few exercises for you to practice. Number 1, state the order of the following matrices. Remember, the order of a matrix, it's always row times column. Second one, which of the following matrices are equal? We've said that for two matrices to be equal, the corresponding elements are same and the order is the same. Same order and same corresponding elements. And number 3, find the value of the unknown. Okay, so you need to find the value of X or Y or Z depending on the matrices. Right? Okay, these are 2 links where you can get further information on matrices. Okay, so what have we learned together today? We have seen how to interpret a matrix, the different words used for matrices. For example, you know that a matrix is an array of numbers. We have seen that these numbers, they are called elements. We know that in matrices, you've got rows and columns, right? We have seen together what do we mean by the order of a matrix and how to identify the different types of matrices. Okay? We have also seen together how to work with equal matrices. We have worked a few examples for you. Now, this is the first part, right? What you need to do now is go through your textbook, work the exercises that are in there, okay? If you have any problem, please ask for help. We are here. Good. So that's it. I'll see you in the next video for the second part of matrices. Until we meet again, it's goodbye for now.